the direction sound field of sound pressure level. So you need to have sound V total. We can move slowly starting from part 3 because quite I convert here and there, so make sure you understand why I do that converter noise. L W is 54 dB. Okay, so first I want to find the sound power for each machine. So each machine now is 2.512 times 10 power negative 4 watt. Previously is how much? 2.512. How come the same? 10 dB different or? Did I calculate correctly here? Oh. 10 times negative 3, we are negative 4. 10 times different. Okay, just the value is similar, but this one negative 4, that one negative 3. Which check, make sure you calculate. Okay, now the total sound power will be W1 plus 4 W2. And which is the new one? W1 is how much? W1 5.093. One machine is 1,000. So the total cost we have to pay is 4,000. Okay. Now question number 5 is actually costing. As engineer, you consider the cost, right? What if you install acoustic tile with an average absorption coefficient of 0.6 and it's around 15 ringgit per square meter? Which one is cheaper? Okay, you have to make the adjustment and calculation of cost. So this one 88 dB cannot accept. But after you add in the sound absorption coefficient, 79.7 dB below 85 dB, it's very good. But cost is 4K. Okay, now I consider the second case. Second case is you want to install the acoustic tile. So the alpha will the A will change like the submit. So what will be the new LP if I change the now the filter sound is 100.3. Apply the noise control treatment on the machine, cost 4,000. Second case is install all the acoustic tile on the all 6 surface. The cost is 9,000. Both fill the requirement of the sound level below 85. Which one will you choose? Sorry? Or you have the third method? Third method is, do you need to cover all the surface with acoustic tile, or you will choose certain surface to cover with acoustic tile? Yeah, correct. You don't need to cover all the surface. You can only cover the wall or ceiling. Okay. So now we need to calculate how many surface is needed. Okay. So based on the requirement, 85 dB. This is our LP requirement. Okay, so I apply the same equation. 85. The sound power is 100. So now you need to find the average alpha that needed. Okay, it's not 0.6, 0.6 is more than that already. You see it dropped to 76 already. Actually 85 is good enough already. Okay, I want to see what is the alpha needed, then you can decide how many area you need to cover with acoustic tile. Okay, so now we find alpha. Just need 0.19, but actually for my case, how many surface I need to cover so that 0.19. So again, I come up with the equation for Sabi. Okay, so 4 surface. Here, I need to make the simultaneous equation already. I know that the average sound absorption coefficient must be 0.19. Okay, so I get the value of A. A is means that the sound absorption is Sabi. 0.1 equivalent to 0.1A plus 0.6B. 0.1A is a surface area that not covered with the acoustic tile. 0.6B, B is a total surface area that covered with the acoustic tile. Okay, and I know that total surface will be equivalent to 600. Okay, now I solve the issue, solve the question. Cover with the acoustic tile is 108 square meters. Okay, times the cost, Rn 15 ringgit per square meter. The total cost is Rm 1620 only. Okay, so we have three scenarios here. So which one you will choose? Definitely you can pick the third one. The cost only 1,060, greater than 4,000 and 9,000. This is your boss want to see lah. You solve the issue, but you use the minimum cost to solve the issue. Okay? $4,000.
Yeah, we calculate it out or is it given?
You mean the first one?
Yeah, that one. Yeah.
Or the first case, the cost of applying noise control to one machine is 1,000. So we have 4 machines, 4,000. So you see that the noise control apply on the machine itself, but not on the surrounding. You buy the machine from, you buy the aircon from Daikin. So Daikin already do some kind of noise control inside the air conditioning system. So you buy more expensive because you want noise control. They add in extra feature. So extra 1,000 per machine. So that the cost of total 4,000. Okay, so buy the acoustic down to all the surface, but we just need to apply on 108 square meter of the surface. Okay, this one clear. So cost 1620. But actually, to be safe, if you follow DOS requirement, 85 dB is a threshold. But as long as you more than 82 dB, the DOS will require you to do the NRA, non-risk assessment. Because the comment given by the DOS is 82 dB, 3 dB different. Maybe it's your device not measuring correctly. Okay, so they pick some buffer. 82 dB and above, you have to do NRA. But 85 and above, you have to take the action to solve the issue. Okay, that's all for example 6.6, and that's all for entire semester. We have covered all the syllabus. Okay, now let's speak the degree 12. Okay, the rest of the time we'll discuss past year questions. Okay, we draw the mass first. Body, engine, transmission, and solid suspension. Here, but how it contribute to the system? Maybe you can add together with the engine. Suspension can be the spring suspend the car system. Okay. Maybe I put it in the bottom. Okay, make it the same size. Okay. For mathematical modeling, you always have to take care of one thing: direction. Direction of force and direction of spring should be the same direction. So if you are right in this way, then I put the force in that way. It becomes not valid. Okay, because the force will not compress the. Okay, So we can do it another way around. Suspension, maybe I put it together. So now at least the force will each other. Okay. Bumper, radiator, car body. It's quite hard to separate that because engine and transmission not actually contribute to the engine. Engine mount engine, and then where I want to put the transmission and suspension. Maybe M1 the car body plus the transmission. The last one is the drive line. Put them together. Because it's quite hard to separate. Then you come like this. And then engine also contribute to the heating on the surface. Can I just draw one mesh and a simpler one? Can I draw like this one? Mesh, green, and then here is a wall, and then only one direction. So all the mesh is inside here, all the K inside here. Okay. Something wrong because the question didn't specific how many degree of freedom. Okay, we're going to do this overhead. Okay, and then after that, suggest two possible design improvement that can be implemented in the automobile to minimize impact to the driver. What can you do? Two possible design improvement. So it means that your drawing of the mathematical model maybe 6 marks and 2 marks for one of the suggestion, one of each suggestion. So 6 marks, 4 marks come from the model, 2 marks come from your library. Make sure you put the library now. Okay. Any suggestion? How you want to reduce the impact?
Increase crumple zone.
it means that you add a thickness. Okay, can absorb. Or in fact, so you won't reach the capacitor and driver. What else?
Reduce mass.
Reduce mass. Okay. Reduce mass. That's the method that you can control. It's not a very good idea. How are you going to reduce the mass of the car? And normally, you reduce the mass, then stiffness will also drop. I mean, the internal material properties. For example, aluminium, lightweight than steel, but at the same time, the strength also less than steel. In general. Okay, but you notice that this system do not have damping. Why not you suggest add a damping? Right? So that add a damping material to absorb the impact also can. Okay. Normally, what you can control in vibration is MCK, mass, damping, and stiffness. Okay. But for this case, mass feel like not under our control. But M and K should be okay. Sorry, C and K should be okay. Can I say I put airbag? Reduce the impact one. Can or not? What do you think? Do you think you will get full marks if you say add airbag? Why?
Is it count as increasing damping like that?
No, the question asks to reduce minimize the impact only, ma. It's a function of airbag. I can say you are wrong. Unless I specify the method must become from vibration point of view, then you can do that. Or else the general you can use it. Right. So something like this question is very subjective and you have a lot of freedom. I think minimum student will get low marks for this. Normally 6 marks, 8 marks is quite easy for this question. Okay. Okay, try B. Only one question for that time. The foundation of an industry compressor experience vibration with a maximum displacement of 0.25 mm, maximum acceleration of 4 meters per second square. Okay, to calculate the operating speed of the compressor in RPM based on this given part. So we have displacement. We have the acceleration. So how to solve? We have displacement and acceleration only. Can you find the operating speed? Can you help to find? No idea. Okay. So what's the relationship between RPM and displacement? Okay, we know that displacement for a general vibration I can call it as XD, displacement in terms of time, and it will be in terms of sine wave or cos wave. We call it as a sinusoidal, okay, or harmonic. Okay, so we can get the velocity. And also the acceleration. So from here, I know that acceleration is actually part of the displacement, for example, and it equal to 0.25 mm. Then omega squared x equal to A, which is a 4 meters per second square. So in other words, you can find the omega. Okay.
Okay, ah.
Okay, then try question C. 25 marks are total. So when you see the mark only 4 marks, so you can expect the solution is quite short. And the speed we will consider as an initial velocity for displacement. Okay. So for this case, mass 2000. Mass 2000 kg velocity, 10 meters per second. Stiffness 80 km kilonewton meter. This is the only thing that you have. Damping coefficient 0.02. Okay, so the maximum displacement of the train after engaging the spring and damper. So you want to find the amplitude of the displacement, we call it maximum displacement. So this one, single degree of freedom system, is it a force vibration? No, it's a free vibration. You don't see any external force that back and forth. Okay, not only the force must be harmonic force, then only consider as a force vibration. Okay, so free vibration with the damping, you want to find the displacement amplitude. Free vibration with the damping, you want to find the amplitude. This equation can be used. Okay, and then second part, ask for time taken to reach the maximum displacement. So first one first, maximum displacement. Sorry, it is an equation for force vibration. Copy the wrong equation. Free vibration is one under them. So now this is critical them, over them, or under them. I don't know. Okay, so what should we consider? You find the value of theta. Yes, correct. There you go. So theta E over C. Two square of A M. I think definitely very small because of that being very small. Okay, so definitely will be the under that reading. Very, very small, actually you can take it as 0. So it becomes no damping. Okay. Of course, you want to continue to do the calculation also can. Okay, now the initial displacement. Do we have the initial displacement? Okay. Don't have initial displacement, so we take it as this train will reach here at a speed of 10 meters per second, which is the initial velocity. Okay, initial displacement equal to 0, theta equal to 0. Okay, so we can simplify. Becomes so simple. Okay, and then you find omega n. how to get the maximum time taken to reach this value? 1.581. So you can take at the time it reach here is 0. So 1.581 is meant the spring is compressed to maximum value. So you reach 1.851. So how to get the time? It's a sine wave. This is a sine wave. Okay? Here is 1.85. 1.58, sorry. So when to reach here? This quarter cycle. Okay? This is one cycle, half cycle, quarter cycle. So how long is going to complete quarter cycle? Then there will be the time. So this one is omega n 6.3 radian per second. If I want to change to the revolution, what you get? Sorry, I want to get the time, sorry. How many radian is here?
1.4
Entire cycle, one cycle is 2 pi radian. So this one half radian, half pi radian. Okay. So it means that omega nt equal to pi over 2. Okay, so you get d. Zero point 0.25 seconds. Question 2. Develop the equation of motion and complete the natural frequency of the hanging spring mass system so here. Okay, and then if an harmonic force applied, what is the effect on the system natural frequency? So first you need to come up with a free body diagram. Mass and then the force applied is X. Okay, then equation of free body diagram and equation of motion. Total force equal to effect on the natural frequency. Free body diagram, free body diagram. Oh, no need. You no need to. Okay, I'm going to ask, do I need to add a FT in the free body diagram? Natural frequency definitely not related to FT. Okay, I'll answer the question. I mean the second question. If harmonic force applied on the system, what is the effect on the system natural frequency? The answer is no effect on natural frequency. I should not answer the question. Okay, that's why in the equation of motion we don't need to include the force into our free body diagram as well. Okay, external force. It won't affect the natural frequency, and also end up with you cannot get the answer. Okay, so don't say you apply the force, natural frequency become higher. A lot of students will do that. Natural frequency is a system characteristic not affected by the external influence. Okay, B. The 6 kg firearm has a maximum allowable right now. 6 kg. What's the max? Okay, maximum allowable recoil distance. Maximum distance 0.2 meter. Determine the appropriate spring stiffness K if the recoil mechanism, if the initial recoil velocity is 10 meters per second. Initial velocity 10 meters per second, assuming that the system incorporates a critically damped dashpot. Critically damped. Okay, theta equal to what? We can get the equation for theta over them, under them, critical depth. This one critical depth. Okay, equation for critical depth. You have to use this list of equation always lah, so that you can remember with what equation available here. FT question want you to find K. Okay, so in other words, maximum cannot be more than 0.2. How to get the maximum value? Okay, I simplify first. Initial recoil velocity 10, so recoil displacement 0. So I simplify to okay, then t in exponent equal to 0. So to find the maximum value, you need to do the differentiation. Okay, d x dt equal to 0. So A can be 0 or B equal to 0. You have two options here. So I take the first option first. Negative 10 omega NT plus 10 equal to 0. Negative, so omega NT equal to 1. Okay? So I substitute this into the equation. X max equal to 0.2 equal to 10 E exponent negative 1. How I want to find t from this equation? You hate it over here. Okay, but is A times B equal to 0? Either A equal to 0 or B equal to 0. Okay, so you just try one side, the other side, and the other side. Okay, if both sides are actually can give you answer, both sides can be the correct answer. Okay, yeah, I have two possible conditions. But for this case, exponent side, we are able to get 0. Okay, so the other side, okay, to get 0, and I get omega NT. And don't try to get T alone because we cannot, we don't know the omega N. Okay, just let it